Los anclajes son elementos que trabajan a tracción, con los que se trata de mejorar las condiciones de equilibrio de estructuras verticales, como muros de contención o taludes. Se hacen perforaciones subhorizontales o con inclinaciones entre 30 y 45 grados, en las que se introducen varios cables, se inyecta la lesada y se pesan los cables hasta obtener el tonelaje de diseño necesario para el sostenimiento de la estructura. Al entrar a la obra, no olvides todos los EPIs que debes utilizar: casco, ropa de trabajo, chaleco, guantes, calzado de seguridad y protección ocular y auditiva. La plataforma de trabajo debe ser horizontal, estable, con el terreno compacto. Deberá delimitarse y señalizarse de modo adecuado la obra. limpiados correctamente y en perfecto estado antes de conectar el equipo al suministro eléctrico. Se deben extremar las precauciones en el montaje de las placas de reparto y demás elementos de bloqueo de la cabeza del anclaje para evitar cortes, golpes y atrapamientos de las manos. Para el manejo de los equipos de tesado multifilares se utilizará una grúa, camión grúa o carretilla elevadora. Su eslingado se realizará correctamente utilizando ganchos con cierre de seguridad. Debe existir muy buena coordinación entre el montaje y el pesado. Durante la puesta en carga de los anclajes, los trabajadores y observadores se sitúan fuera del radio de giro del gato y se pasará nunca por detrás cuando está en carga. En algún caso, se sobrepasará la presión de pesado fijada en el proyecto con el fin de evitar una ruptura de cables que provoque la proyección de líneas y cordones de acero sobre los trabajadores presentes en la obra. Para el destesado del anclaje, el trabajador debe utilizar los EPIs necesarios para evitar quemaduras y proyecciones, como la pantalla o gafas protectoras, ropa ignífuga, calzado de seguridad, guantes de cuero. El equipo de oxicorte deberá estar en buen estado. Los conductores de la botella de oxígeno deben estar limpios de grasas de aceite. Se utilizarán
תגיד לו גם שישים משקפיים. זה לא יציב.
Overhead power lines are killers. In the U.S., contact with an energized overhead power line is the #1 killer of employees working with or around a crane. The same hazard exists with a drill rig. If power lines are near the work area, special precautions must be taken. Assume all overhead lines are live. At no time should any part of a drill rig be allowed to enter the danger zone that surrounds an energized line. The danger zone clearance should never be less than 10 feet and must be increased at voltages that exceed 50 kilovolts. When equipment is being transported or is moving from one work area to another, there are minimum required clearances for transit under live power lines. If you must work closer than 10 feet to a power line, make sure it is de-energized and grounded before any work is permitted. If contact is made with a live power line, the procedure for all personnel must be clearly understood. No personnel should approach or touch the equipment until the power is turned off or the contact has clearly been broken. When working in the vicinity of overhead power lines, all employees must be trained on the hazards associated with this dangerous work environment before work begins. It is a best practice to erect warning lines, signs, or barricades to identify and then prevent encroachment of the danger zone when working near overhead power lines. Warning: moving a live electric line should only be performed by a trained, qualified person. If a person is within an energized zone, they should exit the zone by keeping their feet in contact with the ground, shuffle one's feet, or move heel to toe until clear of the energized zone. The clearance distances stated are for work in the U.S. For work outside the U.S., please consult your local or federal occupational safety and health requirements for the safe, clear working distances in your area. Before any drilling or other type of excavation takes place, it is necessary to check for underground hazards. Someone from your company must contact the local Call Before You Dig system. Most areas require a minimum of 48 hours or 2 working days advance notice for this survey to take place. Consult your local utility locate service for accurate details and requirements. All underground utilities such as electric, gas, telephone, and fiber optic lines or utility vaults must be physically located prior to starting work. If drilling adjacent to or under an existing structure, make sure that you will not drill into the structure below grade. Check your elevations. Remember, you simply cannot afford to take a chance with underground utilities. The repair costs for damage to a utility can be enormous. The possibility of someone losing his or her life is even greater. So call before you dig. Other dangers the crew might encounter include work in limited space, site obstructions, and the equipment and crew activity of other contractors on the same site. Special attention should be given to traffic whenever work must be done on or near roadways. Most states require posting signs, cones, and even trained personnel if work is to be done near traffic. Hand signals must be clear and understandable by all employees involved when using a crane for lifting material. When lifting any load, it is essential that one qualified person be responsible for giving all signals to the crane operator. During the entire lift process, this individual must have absolute authority and no distractions. While your drill rig may have the ability to use percussion as well as rotation when driving casing, it may not be designed to extract casing when in percussion mode. Consult the operator's manual or the manufacturer for accurate information. Severe damage and/or injury may result with improper use. If you are using electric-powered tools, you must keep your power cords high and dry and not allow them to lie in water or muddy conditions. You must protect yourself by using a GFCI or ground fault circuit interrupter plugged in at the power source. Today, many portable generators have GFCI protection built into their power outlets, but not all do. A circuit breaker alone will not protect you from shock or electrocution. A fully inspected and properly maintained tool, power cord, and GFCI will. Compressed air may be essential to drill rig operations. For pneumatic-powered equipment, an airflow reduction valve should be installed at the air compressor outlet. This device will shut down pressurized air moving through the line if there is a blown hose, broken connection, or fitting, almost immediately. Consider 900 cubic feet per minute of compressed air at 150 pounds per square inch flowing through a 2-inch diameter hose only 3 feet away from you. You see why this device may save your life. Once again, secure all supply hose connections with either a whip check or a whip sock. The environment plays a big part in worker safety. Proper work clothing is essential for all seasons. Dress in warm layers during the cold winter months and wear light-colored clothes in the summer. Remember, the use of sunblock is strongly recommended all year long, as the sun can damage your skin and cause possible skin cancer. Rain gear is an obvious choice if it is raining, but it may also keep you dry if you are drilling with water or encounter groundwater or are mixing grout. Good lighting is essential if you must work after sunset or in an enclosed structure. Place the lighting in such a way that it provides adequate illumination but does not cause dangerous blind spots or shadows. During the course of installing an anchor or micropile, it is possible to encounter existing contaminated soils or water. The contamination may not have been noted on any of the soils reports, so you must be prepared for such an event. If you encounter strong chemical odors or notice a dramatic change in color of any groundwater or soils, you should stop drilling and notify your supervisor immediately. If possible, move away from the drilling location and set up at another. The potential contaminated material must be analyzed to ensure it will not harm you or your coworkers before you return to that location. Drilling through concrete, a few soils, and most rock will generate some amount of dust. Within this dust, it is highly likely there will be particles of silica. Exposure to silica dust is hazardous to your health. Warning: Fortunately, there are several methods you can use to control dust exposure when drilling. Mechanical dust collection using shrouds, suction, and filters is one method. Water misting the dust as it exits the borehole is another method, as is injecting water through the drill steel as drilling takes place. You must choose an appropriate method for your site conditions. The dust not only can affect the drill operator and helpers, but all employees downwind as well. So please, control the dust. If it is necessary for employees to use a respirator to protect them from any dust or other contaminants, the user of the respirator must have passed a medical evaluation questionnaire. be fit tested for the respirator, and receive training on its correct use by the employer. Once the anchor or micropile is drilled, some form of tendon or reinforcing steel must be inserted into the borehole. The material may be inserted through the casing or may be inserted into the open borehole. The material may be one of several types, including strands, hollow bar, threaded bar, fully encapsulated, and/or epoxy-coated. The tendon material is selected during the design stages for the project, depending on the loading it will be exposed to. Each manufacturer provides an assortment of connectors and anchorages for their respective products. While they may look similar, you must never use components from one manufacturer on another manufacturer's product. Consult the manufacturer's information for the correct use of hardware and components for your project. Inserting the tendon may be performed by hand. This method requires multiple employees to not only handle the weight of the tendon, but to also keep the tendon free of contamination such as mud as it is inserted into the borehole. Larger or longer tendons may require the use of a crane or uncoiler to safely insert the tendon. When mixing grout, only experienced personnel should be used. Not only is quality control important, so is working safely around the mixer and pump a must. These employees must be trained on the safe inspection, maintenance, and operation of the mixer and pump. Set the mixer and pump in such a way that they are level and secured from movement. Always follow the manufacturer's operation manual for correct setup for your equipment. The mixer and pump must be set up as close to the work area as practical. This is not always possible and may require many lengths of grout hose to be strung out. Keep the hoses away from construction traffic and from causing trip hazards to employees in the work area. All supply hose connections must be protected by whip checks or whip socks. When mixing and pumping grout, a number of potential hazards exist, depending on the methods used. Place all bagged material used in the grout mix as close to the mixer as possible. A typical bag of cement weighs 94 pounds, so it is a good idea to stack this material at least waist high to avoid bending over to lift it. Make sure the material is stacked so it will support itself. Use proper lifting techniques when lifting the material bags. Wear all appropriate PPE, hard hat, safety glasses, rubber gloves, full-length sleeves, and respiratory protection when mixing grout. Cement grout is caustic, meaning it may burn your skin. Wash off any grout that splashes onto your skin as soon as possible. If any grout gets into your eyes, you must immediately flush with clean water or eye wash solution. Medical attention may be required to completely remove any remaining foreign objects and treat any damage to the eye. If a bulk grout mixing plant is used, the employee involved with its operation must go through more detailed training about the unit's operation. Many plants operate using electric power, and as such, proper procedures must be adhered to in order to prevent electrical shock injuries. Most manufacturers of this equipment offer on-site training for the employees. Take advantage of their expertise for a safe and productive operation. Good housekeeping is a must around the grout mixing and pumping area. Pick up empty bags and containers and dispose of them properly. Stack empty pallets out of the work area. Keep the work area as dry and level as possible to avoid slip-trip injuries. Most mixers either have rotating paddles or impellers to mix the dry and liquid materials together. Under no circumstances are you to place any part of your body inside the mixer while it is running. If you must do so, shut down the power supply to the mixer and bleed off any residual pressure and secure the unit from startup before making any adjustments or repairs. Ensure the unit cannot be restarted while you are working on it. Most grout pumps have many moving parts. Any exposed moving parts must be guarded to prevent accidental contact. If the guard is removed for repair or maintenance, replace as soon as possible. If the equipment has inline lubricators, make sure they are inspected to ensure that they are functioning and are filled daily with the correct lubricant. Never open a lubricator unless the compressed air supply has been shut down and the residual pressure has been bled off. Use caution when blowing out a supply hose, either during washout or when removing water in an effort to keep the water in the hoses from freezing. Do not point the end of the hose at any employee or equipment, and secure the end from whipping uncontrollably. Warn other employees this procedure is about to begin and clear the area before blowing out a hose. Pumping grout may be performed under low or very high pressure, depending on the type of anchor or micropile you are installing. Pumps can generate very high pressures. Make sure all hoses, fittings, and regrout hardware are rated for the pressure capability of the pump and protected by whip checks where applicable. Secure all grout tube fittings and couplings correctly, using the correct glue or clamps. Make sure the pump has a pressure relief and that it works. Check the pressure relief daily. There is always the possibility that the grout pump or supply hoses will plug up during pumping operations. A plug in the line may be caused by a number of problems. It may be caused when starting to pump by a lack of lubrication in front of the grout as pumping begins. It may be caused by dirty hoses that were not properly cleaned on the previous day. If plugging conditions in the pump or hose occur, do not attempt to use power to correct the condition. Reverse the pump or release the line pressure, determine the cause of the plug, and then correct it. Remove the plug. Reassemble the system using gaskets, clamps, pins, and whip checks. Then resume pumping. Trying to force material through under jammed conditions may result in serious injury to people or damage to the pump or hoses. Pulling tension, tensioning, and stressing are interchangeable terms describing the application of a stretching force on the tendon. Under ideal conditions, this is a safe operation. However, in the real world of anchor or micropile installation, the conditions are typically anything but ideal. As with the drilling equipment, the manufacturers of the tendon material have established guidelines for the safe handling and tensioning of their products. It is a must for all employees involved with this operation to read and understand the manufacturer's information. Prior to tensioning the tendon, ensure the work area is as dry and level as possible. Since tendon material is typically made from high-strength steel, caution must be used when welding near or cutting this material. If any type of welding operation must take place near the tendon, you must first insulate the tendon material from the welding arc or splatter. Do not use any part of the high-strength steel as a ground connection for welding. Never pass an electric current through a tendon. This can change the molecular structure much like heat does, and result in a failure of the tendon while stressing it. Extra care must be taken to ensure this does not happen, especially when welding wedge plates and/or whalers. Insulate the tendon from any contact. Accidental stray contact may damage the tendon and possibly cause it to fail during the tensioning operation. If stressing a strand-type tendon, make sure the strands are oriented correctly. No individual strand should cross over another as they exit the drilled anchor. If the strands are not aligned correctly, they may bind up or cut one another under tensioning and may fail. The stressing ram typically requires 2 people to set it up on a tendon. This is especially true on a strand tendon. One person must hold the strands to allow the ram to be placed over them. The same is true during removal. If the strands are not held, they can whip around and cause severe injuries. Use proper lifting techniques if manually lifting the ram. There is a difference between oversized nuts and left and right hand threaded nuts. Oversized nuts are made specifically to thread onto an epoxy-coated bar tendon and take into account the thickness of the epoxy coating. Warning: an oversized nut will thread onto a bare thread bar but will not hold the required load. There are left-hand threaded bars and right-hand threaded bars. Each has a different rated strength. Do not attempt to force a nut onto a bar as it may be cut opposite of the nut. Consult the tendon manufacturer for strengths and sizing. Don't guess. Make sure all hydraulic hose fittings are cleaned and the connections are tight on the tensioning equipment. The hoses should not be kinked. If an electric pump is used, a ground fault circuit interrupter, GFCI, must protect it. Do not use a cast iron anchor head in front of the ram to tension a strand-type anchor. A steel stressing head supplied by the strand manufacturer is the only type that may be used for this operation. The cast iron anchor head may break during tensioning and may cause a serious injury. Use the manufacturer-supplied stressing wedges in the steel stressing head and supplied lock-off wedges in the cast anchor head. Clean and inspect the stressing wedges after each use, as they are reusable. Discard the wedges when cracks appear that are longer than 12 threads or at the manufacturer's recommended intervals. Several different loads will be applied to the anchor. After each load is applied, a reading will be made from the dial indicator. Always position the dial indicators or other form of measure on either side of the ram. Under no circumstances is anyone to be in front of the anchor when stressing is in progress. Some micropiles are tested in compression as well as in tension. A compression load test must be set up correctly, with care given to the testing frame and its accessories. The frame should be set up level and accurately placed over the micropile to be tested. Once again, the precautions regarding the use of the hydraulic ram, reading instrumentation, testing hardware, and the test frame setup are very similar to those for testing a tieback anchor or soil nail. Regardless if you are working on an anchor or micropile job, safety must control every aspect of your thoughts, both at work and while at home as well.